Well, my computer is on a very janky setup that makes it very easy to fall over. So the last video ended abruptly as my computer nearly fell to the ground, and so I caught it. So we will continue on in part 2 of this. So what I was talking about here is if we look at this type of point here, this would be, again, a critical value. At this critical value, we see that the second derivative is going to be positive. This is concave up here, and this corresponds to a relative min. So you can look at relative max and mins using either the first derivative test of increasing to decreasing or decreasing to increasing, or using the second derivative test. I personally prefer this one. It's just nice and easy. Now, we are talking about critical values. Again, those are values where the function is defined and the derivative equals 0, or the derivative is undefined. But again, remember, the function is defined at those values. Intervals of increasing and decreasing, these had to do with our relative max and relative mins. If we have some type of interval, let's say we have a number line, say 0 to 3, we can test our first derivative. So if our derivative is positive, then that means that our function is increasing. If our derivative is negative, that means our function is decreasing. If on this interval it is also negative, then our function is going to be decreasing, but then it's going to be increasing. So we have our intervals of increasing and decreasing. We look at our first derivative. But intervals of concavity, if we look at the second derivative, that tells us concavity. So if my second derivative is, say, positive, this means that my function is concave up on that interval. If my second derivative is negative, that means my function is going to be concave down. And then here, let's say, again, this is maybe negative. Again, we have concave down, and so we could go back to the graph sketching and be able to sketch the graph where when we have something that is decreasing but concave down, our graph would look like this, or it would look like this, and then here it would look like this because it's increasing while being concave up. So increasing, decreasing, look at the first derivative. Concavity, either concave up, concave down, look at the second derivative. So then if we look at inflection points, these are going to be where the concavity changes. So we see concavity is going to change here at 3. Concavity does not change at 0. So x equals 3 would be an inflection point for this example. Rolle's theorem, so remember what we had with Rolle's theorem is if we had the function value was the same on the endpoints. So if we have f of a is equal to f of b, what that means is any way that I try to connect a continuous function, there must be a point where the derivative equals 0. So I am forced to have the derivative equal 0 as long as f of a equals f of b, and this is continuous on that interval from a to b. But the mean value theorem was an advancement on Rolle's theorem. The mean value theorem allowed us to have different values. So this would be f of a, and this would be f of b. And however I draw this doesn't matter. The difference, though, is that you could define the secant line, or the slope of the endpoints. There must be some point on the interval that has the same exact derivative as the slope here. So there must be the slope of a tangent line must be equal to the slope of the secant line for something in between here. And again, we needed to have that this is going to be differentiable on the interval, and it must be continuous on the interval. So as long as it's continuous and differentiable, what that means is that there is some point C where this f prime of C is equal to f of b minus f of a all over b minus a. And then the last thing is the secret to the best chocolate chip cookies. It is salt. You want to sprinkle a little bit of sea salt on top of your chocolate chip cookies the next time you make them. I guarantee they will probably be better than your normal chocolate chip cookies. And this is if you're making them by hand, which is the best way to make chocolate chip cookies. So hopefully that equips you with everything that you need to know going into your second calculus exam.